Today we are going to do this exercise. Essentially, we are trying to create a Python code in Edublocks to plot isosceles trapezoid. It has a bottom width of 10, a top width of 4, and a height of 4. So in order to create this trapezoid in Edublocks using Python, we have to know one approach. I'm using one approach. There may be several approaches, but one approach is to know the sides and also the angles. So what happens in this case is we start from a certain point, let us say here, and we move, let us say in this direction, certain distance, and when we reach at this point, we are going to make a change in direction. So this is the original direction. Then we are going to make a change, to the left. And in order to make the right change, we have to know what this angle is, and also we have to know what this distance is. And when we move from this point to this point, again we have to know, because the original direction is like this, we have to know what angle change we have to make and in which direction we are making that change. So these are the steps involved. We have to know all the changes in angle as well as all the distances. Since this is an isosceles trapezoid, these two sides are going to be equal. In that case, if we determine the distance, one of the distances, it's going to be enough. Okay, let me go to the next step. So as I said, we have to determine the angles. In order to determine the angles, it is good to create these imaginary lines, these dotted lines. These imaginary lines are just to show us which direction we are going originally, so that we can come up with, like how we can measure, the deviations we are making or the angles we are changing as we move forward. So in order to measure this, we can make use of this protractor. How the protractor helps us is, for example, I want to measure this change in angle. This is what I want to measure. In order to measure this, what I will do is I will drag the protractor and put it here at the point where the change in direction happens. And that way, when I put it there at the center, the origin of the protractor, then it will give me the measure of this. So these green levels start from 0. So starting from 0 all the way there, the angle looks like we have 127 degrees. So that means the change we are making here is around 127. So similarly, we are going to measure this angle, all the three angles where we are making a deviation. So in this case, when we measure the angle, we have to measure it from this side. So start from 0 here, and it goes somewhere, like 53. You see this red dashed line passes through 53. So the angle that we see here is 53. Similarly, we measure the third angle. For that, I have to flip this. And now I place it right there at the intersection. And then we measure, you see, with the green levels. If you see, we measure this way. Actually, the angle change in this case is going to be like that. So if you measure the green levels, which started from 0 here, it is again 53. So what this means for us is, now using practical geometric lessons that we had in the past, we were able to determine, the angles that this is deviating. So in our case, we are going to move forward by the given distance, by the given width. Then we make a left turn, 127. Then we move this distance. Mind you, this distance is not determined yet. We will go in the next slide. We will see how we can determine that. And then we go a certain distance, and then we make a left turn again of 53 degree. And then we travel this distance of 4, and then we make a left turn again. And finally, when we move this much distance, we come back to our original point. So we started from here and we are moving. So far what we did is we determined all the angles involved. Let me move to the next slide. So the protractor helped us to measure these angles. These angles are important to draw this trapezoid using Python. So the next step, once we determine these angles, as I said previously, we have to know what these two distances are. These are still unknown. Again, we are going to use geometry principles to determine this. And let me go to the next slide. So you see, this is our trapezoid, but we know that a trapezoid is a combination of, like, especially if it is an isosceles trapezoid. So if you split it like this, you have two triangles and one square in this case. So you see, I split it, so the square is the one in the middle. You see, 4 by 4 square. Whereas, you know, the triangles, you can see, because this height is 4, now the height of this right triangle that we have on this side is 4. The height is 4, but since this is 4 and the total distance from here to here should be 10. So if the square part takes 4, then the two triangles takes 6. So 6 divided by 2, we have 3. So we know this 3 by 4 right angle triangle. And for that, you can easily determine the diagonal or the hypotenuse using Pythagoras theorem. So this formula was applied. So when you take the square root, you can remove this. So this is the formula that you see. So we easily determined the hypotenuse. So if we know 5, this one is 5, then we know that this side is also 5. So it means that we have now determined all the sides of this trapezoid plus all the angles. So if I go to the next slide, you will see clearly, you see, we have all the sides and we have all the angles of deviations. I'm going to show you another important geometry principle. So this is our trapezoid, but if we try to draw this in Python, because these lengths are small, then we'll have a very tiny trapezoid and it will be difficult to visualize. So at this stage, what we would do is to use a scale whereby we are going to enlarge our view. That means I take a scale of, like, for example, if I multiply all sides of this trapezoid by 20, if I multiply this by 20, and I have to apply the same thing to all sides. So as long as you multiply all sides by the same factor, by the same scale, then you are going to, obtain a similar trapezoid. So as long as they are similar, all the angles will be the same. So, I multiply this 4 by 20, I get 80. 5 by 20 is 100 for the sides. This is 200, the bottom one, 10 times 20, and this one is 100. So these two trapezoids are similar. So if I plot this for our visualization, actually we are doing this for visualization. Even, when civil engineers draw, a map, they usually do this kind of scaling on a drawing so that, they can clearly see the diagram. Otherwise, if they use the exact lengths, so the diagrams will not show up properly in the maps, in the blueprints. So this is what we did here. We just used the scale of 20 and we multiplied them. You can take other scales if you want, 10, 20, 50, whatever. So the goal of this step is to make it appear large, when we especially use our Python coding in order to draw this, then we need to use a scale like this. So that will be also part of, once we use this scale, let's go to the next step. So this is our, finally, our trapezoid with all sides determined, with all angles determined. Now, what remains for us is to write the Python code. And for the Python code, as I said previously, all we do is replicate the process. You see, we start from a certain point, and then what we do is, in the first step, we move forward by 200. So this is what we do. And when we do that, we arrive at this point. And when we arrive at this point, we have to make a change of direction, and that is by 127 degrees. And we are moving to the left, mind you. If we say right, then we are moving this way. But this for the direction we are following is to the left. That's why you see here it says left 127. After you make a left turn, then you have to move forward by this distance, 100, shown here. You see, this is the fourth step. The Python code is going to be sequential. It is just following the logic of the drawing of this figure. So after we move 100, we arrive at this point. So when we arrive at this point, again, we have to make a change of direction. And again, you see we are making a change to the left. And by how much? 53 degrees. So this is the code. So you can add to this code, for example, after you make a left, a 53 left, then you have to move 80. So here in this code, you can write forward So I added this step. So what you did is you moved forward by 80 and you will be arriving at this point. Now at this stage you get the hang of it. So it means finally, the steps that remains is to make a left turn of 53 degrees and then move 100. So when you finish that step, you are back to your original spot. And when you are back at your original spot, then it means that you have completed the whole cycle of drawing this isosceles trapezoid. So this is how the steps we are following looks like. So we did, so far all we did is a preparatory work on the geometry of aspect of it. And once this geometry aspect of it is done, the next step is gonna be to write the code. So this is an exercise for kids to learn Python. We are using Edublocks. Edublocks is an open source free software where children can playfully use blocks and move those blocks. And there is this package called Turtle. Turtle is like the drawing tool in the Python in Edublocks. And so we name our turtle T. In this case we called it T, but you can call it any other name. But once you name it, you have to follow. So you are telling your turtle to move forward by 200. You see, forward by 200. This is the original direction. By the way, this is the output. What you see here is the output of the Python code. But what we see here is exactly what we have been trying to do. You move forward 200 and then you make a left turn of 127. And then you move 100. This is what we determined by Pythagoras theorem. The 100 is the distance. You move in the diagonal direction and then you make a left turn of 53. And then you move 80 here. And then that angle change of 53. Everything is coded. And then you move 100. Circuit is completed. So that is how it is. We have, as you can see here, we have drawn a trapezoid. And the idea about Edublocks is we want to teach children how to code. So when they use these blocks, Edublocks also creates in parallel this text-based coding. So when in Python, mostly if you are a well-seasoned programmer, then you write using text like this. So you are not going to use blocks. The children, I see, after a certain time, they have to stop using blocks and then they have to start using actual code. In that case, this Edublocks is teaching them, how their code is going to appear as a text. So the children can look at it and they can learn. So this is the whole idea. The important thing is that what is the underlying logic behind this program. It's not just simply drag and drop. There are some coding techniques which show children how to code using drag and drop. But that problem is maybe they don't understand the underlying logic. In this case, we not only teach them programming, but we also teach them how to draw geometric figures like this. And how now in this very example, we have learned about, angles, how to measure angles, how to do calculations of, the hypotenuse using the Pythagoras theorem. And we have also learned about similarities, how we can scale up, the dimensions. So all of this is very important. So the education we give to our children in these days should be very well grounded on logic. It has to be playful at the same time. They have also to understand the logic of it. Python is something that everybody else has to learn nowadays because the movement of artificial intelligence, everything is based mostly on open source tools like Python and R. So learning open source tools like Python is very important. So I thank you for your attention today, and hopefully I come back with a similar video next time. Appreciate it. Have a great time.